Welcome to today's video where we will explore vibe coding, a revolutionary AI-dependent programming technique that's transforming how software is created. First created by, First introduced by Andrej Karpathy in February of 2025, vibe coding represents a significant shift in the development process, allowing programmers to generate code through natural language prompts rather than writing it manually. So what is vibe coding? Vibe coding is an approach where developers describe their intent in natural language and AI tools generate all the necessary code. So instead of manually writing every line of code, developers focus on the high-level problem solving and intent. As Karpathy described it, it's not really coding. I just see things, I say things, I run things, and I copy paste things, and it mostly works. So a key aspect of vibe coding is that users often accept the code without full understanding the AI. What the AI researcher Simon Wilson noted: if an LLM wrote every line of your code, but you've reviewed, tested, and you understood it all, that's not vibe coding in my book. That's using LLM as a typing assistant. So what are the core principles of vibe coding? First is natural language prompting. At the heart of vibe coding is expressing desired behavior of features in natural language instead of writing code. A developer might say, I need a web form with two input fields that calculates a mortgage payment. The AI interprets this request and generates the corresponding code, making English or any natural language essentially the coding language. The next thing to discuss is AI as a coding partner. In this approach, the AI functions as a peer programmer or assistant. The human's role shifts to guiding the AI, reviewing the output, and clarifying the requirements. The developer becomes a director or editor, orchestrating what needs to be done rather than typing out every character of the implementation. Vibe coding involves an iterative feedback loop. Vibe coding is highly iterative. After the AI generates the code based on an initial prompt, the developer tests it and then provides feedback if there are errors. A common technique is simply copy-pasting error message into the chat with the AI and asking it to fix the problem. This rapid debug cycle continues until the software behaves as desired. Another aspect is the accept all mentality. One striking aspect of vibe coding is the tendency to trust the AI and accept it as suggestions wholesale. Karpathy mentioned that he often clicks accept all on the changes the AI proposes without reading the difference line by line. This approach sacrifices some precision for speed and convenience, but if the rationale is that something breaks, AI can fix it in the next round. Another aspect is voice and multimodal input. While not required, vibe coding often embraces the new input methods beyond the keyboard. Some practitioners use a voice command to chat with the AI assistant. Karpathy has used AI speech-to-text tool to speech his programming instructions, meaning he can code by talking without typing. So how does vibe coding differ from traditional programming? So there are different aspects. First of all, development speed, accessibility, complexity in handling, focus, flexibility, learning curve, and maintenance and debugging. In vibe coding, the development speed is faster. The AI assistance generates the code, speed ups the coding, and iterates. Traditional coding is slower, obviously, because you manually do everything and you debug, and the optimization simply takes more time. In terms of accessibility, vibe coding is more accessible and it lowers the barrier for non-programmers because the instructions are now English and the code is generated. Traditional coding obviously is less accessible. Complexity in handling. The complex code is limited by the AI. It struggles with maintaining structures in large-scale projects, and this is where traditional coding shines. It is unlimited. The programmer has full control over complexity and customization. What about focus? The developers with AI can focus on the high-level problem solving by describing the intent, and the AI generates the code. In traditional coding, the programmers solve line by line, very low-level coding, so the focus is a completely different focus. Flexibility wise, vibe coding is more flexible because you can just ask the AI to regenerate the code if you don't like it. You can throw away. It's called disposable coding. Whereas the traditional coding, you have to craft code very carefully. In my view, the flexibility of being disposable code by AI coders is the more important aspect to focus on, rather than the flexibility of being able to craft every single line of code. And then if something breaks, you can fix it line by line. The flexibility of AI outshines the flexibility of traditional coding techniques. The learning curve for AI vibe coding is obviously easier. If you can speak your desires in English and it codes for you, it's easier. In traditional coding, you have to learn specific language syntax, and so it's going to be a steeper learning curve. On maintenance and debugging, this is where traditional coding will shine, because it's the developers have direct access and understanding of the code bases, whereas the AI code may be difficult to debug and it may be bloated code. And so debugging is going to be more if done by AI. So as in sum, traditional programming requires a structured approach where the developers will code manually, debug the errors, and optimize performance. And this requires proficiency in programming, languages, and frameworks and tools. In contrast, the vibe coding prioritizes accessibility, allowing non-programmers to create functional software that can be easily edited. So what are the practical applications of vibe coding? It's rapid prototyping is obvious. Vibe coding can be done very quickly, and then you can create a prototype and then you can enhance that. The coding also increases democratizes the software development process, because now more people can participate and join in software development. You don't have to be a coding expert. As long as you can describe your problem in English, you can create code. The vibe coding also automates the repetitive task and frees up the coder for higher value added tasks, such as debugging or giving it the high level instructions. Various real-world examples of vibe coding include the creation of an event management app that was built over an hour using vibe coding. Instead of manually defining the database tables, the team told AI what they needed, and it generated a schema with real-time updates and error handling were done by the AI. In another example, chemical reaction simulator was done using experimental data. By providing the name of the chemical reaction to the AI identified the relevant mathematical equations and constructed a simulator in Python. And through an iterative process of refinement, the simulation was adjusted to accurately reflect the real-world complexities. The rise of vibe coding suggests a shift in how software is built. AI-assisted development is becoming increasingly common, with companies reporting up to 10x faster completion time for some projects. According to Y Combinator, over 25% of the startups now depending on AI for 95% of the code base. The developer role is devolving from writing code to using AI and giving it instructions as a system architect. And future AI models will likely integrate with domain-specific knowledge, making industry-specific apps easier to build. Now, one downside of this is the code size, the bloated code base that AI generates. I believe that long-term, AI vibe coding will allow users to create applications quicker, but when you have millions and millions of users, this is where human coders are required to optimize the code. And that is a task that remains to be optimized by AI. Short term, I believe that humans will be needed to debug, test, and optimize the code. Vibe coding represents a significant evolution in software development, offering new possibilities for both beginners and experts. And while it may not completely replace traditional coding for complex enterprise-level applications, it's undeniably changing the landscape of programming. And as we move forward, the most effective approach is likely to combine elements of both method, the traditional and the vibe coding, to maintain the control and precision of traditional programming when needed. So how does all this affect patentability? Vibe coding is beautiful for patenting because you're giving it plain English instructions and the software just generates the code for you. So from our patent perspective, we just need to capture the instructions that you give, the architectural level instruction, and how it solves a particular problem can then be patented, leaving AI to do all the detailed work for you. If you want to patent your vibe coding, please come visit patentpc.com. We are here ready to help you to patent your next vibe coding software project. Thank you.